All right, guys, so this next topic, this is something that's really, really, really important on the AP test. We know what the graph of f looks like, you know, if our original function is a parabola, or if it's a logarithmic, or it's a line, or whatever. But we're going to talk about all of the important features between what the graph of f looks like and what the graph of f prime looks like. So remember, f prime is your derivative. And we've come up the last day or so with actual functions to represent what a derivative looks like. So we've got a function for f of x. We can do that whole process that we've done for the last couple of days to come up with what we call a derivative formula. We've got an actual formula f prime rather than just the derivative at a certain point. And so we can take a look at this slope function and then kind of work our way backwards and figure out what the derivative function would look like. So if we look at this first example, this is our original function right here. This is f. We're going to try to find the derivative. And so if you look, we've got all of these different things that are happening here. So like this line, they calculated that this point right here would have about a slope of 4. It's positive and it's pretty steep. And then as I go, my slope is decreasing. Here my slope is around a positive 1. Here when my graph comes to a peak, that's a slope of 0. Because I'm not increasing, I'm not decreasing, just at that moment, I'm in between an increasing part and a decreasing part. Then I start decreasing, so there my slope is negative 1. I continue decreasing. There that slope looks like it's about the same, about a negative 1. And then I finish decreasing to a slope of 0, and then afterwards I would pick back up again. So what we're going to do is we're going to graph a derivative function over here where we can plot all of those points. So here are my x values. These are going to be y prime values when I plot. So I want to go from 0 to 7. And I've got slopes of, let's see, my biggest slope is a 4. So I want to at least go up to 4. And then I also have slopes of negative 1. So basically whatever the slope is over here, that's what I'm plotting on the function. So here at 0, I have a slope of 4. So that means at 0, the derivative is 4. And then it looks like somewhere between 1 and 2, it's not really perfect there, but somewhere between 1 and 2 the slope is 1. So maybe like right there. And then it looks right about at 2 that the slope is 0. And then either at 3, maybe a little bit before 3, my slope is negative 1. And then it looks like maybe it gets a little steeper here. But then at 5, or right before 5, I'm back at negative 1. So I think at 4 it gets a little bit steeper, so we might have a point a little bit lower down there. At 6, the slope is back at 0, and then at 7, it definitely starts increasing, so it's going to be somewhere in the positive range here. But if we connect these dots, we're going to get something that looks like that. It looks a lot like a parabola type of shape. So this is f prime of x. So we're going to talk about some observations. Now these things are really important. We're going to be talking about them many, many, many times over the next couple of weeks. So we're just going to make some observations about the graph of our original function f compared to the graph of our function f prime. So notice right here that anytime that f is decreasing, that happens from c to e right here. This whole chunk where my graph is decreasing, that's where my derivative is negative, because something that's decreasing has a negative slope. So from here to here, the derivative is negative, whereas from here to here, my original function was decreasing. So everywhere that f was decreasing, f prime ended up being negative. And then we can see the opposite. Here my function, my original function was increasing, and that's where my derivative was positive. And then after this point, my original function was increasing, and I go back to being positive over here. So f is increasing. That's where f prime is positive. And then my last thing, here where I've got a slope of 0, we're going to say that's somewhere where my graph would have a horizontal tangent line. That's where I have actual x-intercepts here on my f prime. Okay, so those are 3 really important features that we're going to continue to talk about. So, example 2, suppose the function f above right here represents the depth of water in a ditch along a dirt road. So, it increases, then it decreases, then maybe it increases again. What does the graph to the right represent? Well, this represents the rate of change of the amount of water. This tells us how the water is changing. So here the rate of change is positive, which means I'm gaining more water as the days go by. My rate is decreasing. So that means it's gaining water, but the rate at which it's gaining water is slowing down. And then when my rate of change is negative, that means I'm losing water. When my rate of change is positive, that means I'm gaining water again. And so the units along the y prime axis, that would be in inches per day. Describe what happened to the water in the ditch over the course of the 7-day period. So the amount of water increased until it reached a max, which is what happened right here. So it increased until it reached a max. And then here, so this actually represents the maximum value, because that's when it has a rate of 0, and then it switches to go below the x-axis. So it's increasing till it hit a maximum, and then it starts decreasing, and that's when its rate of change was negative. And then it reached its minimum value. And that's what happens over here. It decreases, and then that's the least amount of water we ever have, and then it starts increasing again. It's increasing after that point. Okay, so the weather during the 7 days. This is kind of an interpretive problem. You might see something like this. So what's happening there is here, when my amount of water is increasing, because this is a positive rate of change, so the amount of water is increasing, that means it was raining. I'm gaining water, I'm gaining water. Then, of course, it stopped raining. And so at some point during that range, whether it stopped raining, I don't know if water was seeping into the ground or if it was evaporating or whatever it was doing. And then, of course, it started raining again. And that's when the amount of water started increasing again. So when was it the wettest? The wettest is at this point here. That's when I had the most water gathered. So we're going to say that's at about 2. And then the driest would be my low point here, and that would be point F, which is at about 6. And so you can see that on this graph as well. This 0 right here, this is when my rate of change switches from being positive to negative, so that actually ends up being the largest value because I'm increasing up until this point, and then I start decreasing. So I'm gaining water up till this point, then I start losing water. So when I've gained up until this point, this is going to be the largest amount of water that I ever have, because after that I start losing it. Then I'm losing water through this whole point, and then this is going to be the least amount of water I ever have, because after this point I start gaining it again. Okay, so how does the graph of the derivative help? So that is when it hits the x-axis, and that's what I was just walking you guys through. So when it hits the x-axis, either it crosses from being above the x-axis to below the x-axis, or vice versa. Okay, last little question. Interpret the significance of point C in terms of water in the ditch. How does C prime reflect that in terms of rates of change? So C, the reason we care about this point is because that's the maximum amount of water. And then this point right here would be your C prime. And this, again, is when the rate of change switches from being positive to negative. So I'm gaining water, and then after this point, I lose water. So C itself is a max on the original graph. And the reason I can tell it's a max is because C prime, the derivative switches from positive to negative. Okay, let's get, where's my next page here? Here we go. Okay, so last little thing we're going to do is sketch the graph of f from the graph of f prime. So this is a little tricky. This is f prime, that's my derivative. So this says, this point right here, my derivative is -1. So f prime equals -1. That means anywhere to the left of 1, my derivative is going to be, a -1. And then up here, my slope is 2. So that means anywhere from the point x equals 1 to the right, my slope is going to be 2. So we assume f is continuous, we've got that right here, and we assume f of 0 equals 0, so we've got a point to start with right there. So what this says, right at this point, is that anything to the left of 1, anything to the left of 1 has a slope of -1. So I'm just going to draw a line that has a slope of -1. It goes through this point that they mentioned, and then it stops right here at x equals 1, because that's when this derivative of -1 stops. So I'm just drawing a slope of -1. And then from 1 over to the right, I have a slope of +2. So from here, I want to make sure I go from this point up 2 units and over 1. So here, I want a slope of, whoops, this needs to go a little lower. So then I want a slope of +2 over to the right. All right, so this, I have a slope of -1, and then over here I have a slope of +2. Now notice here, I have no derivative, and that's what it shows right here, because my left derivative does not equal my right derivative. So that's it for now. We are going to do the AP problem during class together.